Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to talk about the PDF and the CDF. So we will write PDF as a small f function of x, while CDF as the capital Fx. Keep in mind, they are abbreviations for probability, density, function, and CDF as the cumulative density function. I will also, like with this video, to address a normal misconception that comes with econometrics and these two concepts, and that is height versus area. So it'll become a lot clearer why there is a misconception between height and area in terms of probabilities. And by the end of this video, hopefully you won't have those misconceptions anymore. So the misconception states that, or like stays in the fact that people think that the height of a curve is a probability. So for instance, let's go and look at the bell-shaped curve that we have seen and attributed to the normal distribution so far. And for most of you, if you look at the height, if you haven't really thought about it, might be very easy to think, oh, that's a probability that I can associate there. The thing is, it's not. And I will show you where probability actually lives in this graph. The curve itself, so the curve itself is what we will call the PDF. So this is the lowercase f of x. And the key word for here is density. Okay? Because clearly what it's saying is that the height of the curve will tell you where values are more likely and where they are less likely. So if you are in this kind of height, it means like you are more likely to see a value that falls under this sort of like, let's say, entire range in here or anywhere else, okay? However, it's not telling you exactly the probability. Okay, so height is not probability. And also keep in mind, a single point also has probability 0. Okay. So where is probability coming from? Probability comes under the curve. So probability is the area under a curve. And keep in mind, this doesn't have to be just a nice bell-shaped curve that you're looking at. It could be a function that has a PDF that looks like in a weird shape like this one. And even in this particular one, your probability of seeing a value that, let's say, is between value A and B is literally the area covered by where these two values are indicating your range. Okay, so the probability would come under the curve's area. Normally, we will write it as like probability, let's say, of observing a particular value x out of your variable x that is greater than a and smaller than b. Okay, and when you write something like this, what you mean is that the area, again, under the PDF between A and B. This is also the reason why you can sometimes have tall and narrow regions or short but wide regions that have exactly the same probability. Now, the CDF or the cumulative distribution function is just another way to keep track of that area. And that's where the CDF comes into play, basically. So a way to keep track of the area under the curve. More defined more verbally, we can also say that the CDF at a point X is the probability that X is less than or equal to a particular value X. Okay, so it means that in here, as our value X, for instance, moves towards the right, you are going to see an accumulation of areas. So if I add also value C here, including, so we have the black shaded area plus the gray shaded area. And if my X value increases even further to value D, then I'm adding also the red shaded area. So I keep accumulating the areas under my PDF in there. And as I can see, the probability grows as my values are also growing. Which means that if you have a graph showing you the CDF curve, the CDF is not a curve that goes down because, again, as your X increases, your shaded area is also increasing. So how are the PDF and CDF connected exactly? There is a mathematical relation between the CDF and the PDF because keep in mind, so far we've seen intuitively what they are showing to us. So the PDF is basically telling you how dense the probability is at each point. Instead, the CDF is telling you how much probability has piled up so far. Okay? So the CDF intuitively is just the area under the PDF minus all the rest. So for instance, if we go back to our normal shaped bell curve, in here, if we have a value X in here, what the CDF is going to tell you, so the area that you have until this value X is the entire area that you have under the bell curve, okay? So entire area, which for you in terms of probability wise should be equal to 1, because that means you're covering all possible options in there, minus whatever you're not including, okay? Which in this case, if you think about it, is everything that it's like on a higher value than X here until this X. So this is the area that I'm not including. So you can think of it either how much accumulates until the X or the entire thing minus this thing in here that hasn't been included. Okay? Mathematically, there is also a way to talk about the relationship between the CDF and the PDF. So your PDF is the function that you find out of finding the derivative out of the CDF. So, or you can write it as d over dx of f of x, or you can do the opposite and find that the CDF, which again is the probability that you see some values greater or smaller than your x, is just the integral of your PDF function from whatever minus infinity value until x that you have. Okay? So mathematically, this is how you'd write them. Most of the times you don't really have to do these kind of exercises, but it's still good to know the relation. Otherwise, you already know visually and intuitively what they are doing for you. Now, why do we inference? Like when we do inference, we constantly ask questions like, what is the probability of observing something this extreme? Or how likely is the estimate under the null hypothesis? These are questions you're going to hear all the time in econometrics, and we are talking about probabilities that will be computed using areas, not heights, with bell-shaped curves like this one, okay? So this is also why the reason whenever you talk about p-values, for instance, or critical values, they are all read off or coming from some sort of table that gives you information on the CDFs. Okay? Also, tail probabilities are areas. Okay? So again, you will be referring to the CDFs because ultimately PDF, once again, shows shape. So that's how I know I am working with a bell-shaped curve. But what gives me the probabilities and then my answers to all of my inference questions, what is the probability of observing something this extreme and so on, CDF shows probability. And probability always lives in area. Okay. Hope this was helpful. These are all concepts that are going to come over and over again, especially as we will talk more often about the normal distribution or the standard normal distribution. However, hopefully now you have a way to distinguish between the two and a way to know which one of the two you're always using, although you might not be voicing it out. Hope this was helpful, and I'll see you in the next video.